Hello and welcome. This is Bijan Hushiar. This internet network consists of two Cisco 2911 routers, two Cisco 2960 switches, three PCs, and two servers. We are going to configure static NAT, meaning having a web server in a local area network that is not accessible by public because it has a private IP address, but we want to configure a static NAT so public can access the web server that we have in our local area network. Devices are already configured with IP addresses. The router called NAT has two interfaces working. Interface G00 is configured with 192.168.1.254, and serial 000 of it is configured with 209.209.209.30/27, which is 255.255.255.224. The serial 00 is configured as DCE by a clock rate of 64,000. The second router called public router or public router 2 also has two interfaces, one serial, one gigabit interface, and they are configured with the IP addresses that you see in here. The gigabit is configured with 19.19.19.254, which is a registered IPv4 address, and the serial 000 is configured with 209.209.209.29/27. Supposedly, public router 2 does not belong to us, belongs to another organization. That organization has created a default static route on it for packets to receive, to reach the NAT server that we have. We need to therefore configure our NAT server with a default route to send packets for outside network out of its serial 000. So that's the first thing that we do. We are in privilege mode. We go to global configuration mode and we perform IP route. Any network with any subnet mask, send it out of serial 000. Let's go ahead and perform show IP route to display the routing table of NAT server, two connected networks, and one default route that we just created. Let's display the IP addressing scheme of the NAT server. Do show IP interface brief. As you notice, G00 is configured with a private IPv4 address, and serial 00 is configured with a registered IPv4 address. Although public router supposedly is not ours, but since it is packet tracer, I can perform some show command to display the configuration of it. To show IP route, to show Oh no, we are in privilege mode. I don't need to show IP route. There are two connected networks and one default route. Let's display its IP addressing scheme. Show IP interface with. It shows the IP address for G00 and serial 000 of it. Now we want to configure NAT, meaning for this server to translate the the private IP address of this web server, which we call our web server, to a registered one. Let me show the IP address that this one has. This one has a private IP address, which is 192.168.1.253 with the subnet mask of 255.255.255.0. We want the NAT server to be translating that to a registered IPv4 address, so people from other side of the internet, from other networks that do not belong to us, be able to access the web server that we have on that server in our local area network. The configuration is done from the global configuration mode, IP, NAT, inside. Then after inside, there are a few keywords that we can put after source keywords. One of them is list, one of them is static. List is being used when we have an access list and when we are configuring the dynamic NAT and PAT. But since it is a static, we use the static keyword. Static is 1 to 1. After this, we have to put the IP address of the source device that we want to be translated by the NAT server into a registered IP address. The private IP address that we have for web server, our web server is 192.168.1.253. We want the NAT server to translate it to this one, 209.209.209.1. Okay, and this is configuring the static NAT. We have to also identify the inside and outside interfaces to the NAT server. The inside interface is G00, the outside interface is serial 00. So we need to access those interfaces and configure them accordingly. First, we go to interface G00 and we say IP NAT inside. This is our inside interface. Exit to global configuration mode, access serial interface, and we configure it as IP NAT outside. That's it. NAT is configured. Now let's assume we are one of the users of the network that is not ours and they want to access the web server that we have over there. We go to PC3, we go to desktop, we open the browser and we type the registered IPv4 address that we configured in the static NAT, which was 209.209.209.1. We don't type 192.168.1.253, which is the actual IP address of the server we named our web server. And then we hit go, and then we access the website on that server, on that web server that is located in a local area network. And it says if you successfully accessed this site from PC3 in your outside local network, we have configured the static NAT correctly on our NAT PAT router. Now that we have done the static NAT configuration, let's go to NAT server and perform a couple of show commands. Let's go to privilege mode, show IP NAT translation. It shows that this IP address, which we configured in the static NAT through port 80 for HTTP access, is the translation of this private IP address or the actual IP address of the web server. And the outside device that access this site has this IP address. The source port of it is a random number. It's not 80. Destination port must be exactly related to protocol that we are using to access. So this is configuring static NAT. We have already configured a static NAT for computers from internet to access the web server that we have in our local area network on this NAT server. Now we want to configure dynamic NAT with a pool of 5 registered IPv4 addresses so our PCs in the local area network can access internet. So we go to the NAT server. First, we need to create a pool in the global configuration mode. We go to global configuration, IP NAT pool, and then we're going to give it a name, any name that suits your network. I'm going to call it pool-1. Then I'm going to add the 5 registered IPv4 addresses that are to be used in this pool, and they are 209.209.209.2, starting with that, ending with 209.209.209.7. 2, 3, 4, 5, 6, and 7. That's 6. I'm going to make it 6. So I have 5 IPv4 addresses in my pool. Then the keyword netmask, followed by subnet mask of these IP addresses in the pool, which is 255.255.255.224. The pool is created. Then I have to create an access list allowing PCs in the local area network in here to use the services of the NAT server for translation of the private IP address to the registered IPv4 addresses that I added to my pool. So I'm going to create a standard access list. The command is access-list. Since it is a standard, I have to give it a number below 99 and below. I want to permit the network address, which is 192.168.1.0, with a wildcard mask of it, which is 0.0.0.255, and that indicates any IP address with the first 3 octets of exactly matching 192.168.1, and doesn't matter what value it has in its 4th octet, will be allowed to use the NAT services on the NAT server. And then I'm going to configure the dynamic NAT IP NAT inside source list. After the keyword list, I have put either the name of the access list that I created or the number associated with it. I put the number 1 space. one. Then after that, the keyword pool, followed by the pool name that I created, pool dash one. IPNAT inside source list one, pool one. After that, I have to press enter. It is created. So NAT, dynamic NAT with 5 registered IPv4 addresses in the pool created to be used by these PCs with private IP addresses that internet authorities would not allow them to go to internet with. This range can be used for them to access the internet. Supposedly, this network and this particular web server. Let me check to see if I have all the routes created on this router. Do show IP route. Yes, I have all the routes that I need, 2 connected ones and 1 default route that I needed. Now, I can go ahead and see if I can ping any of these devices or access this web server in an outside network, supposedly in the internet. Go to PC1. First, I try pinging my default gateway to see if I can ping my default gateway 192.168.1.254. Normally it takes a while for this process to work, so you've got to be patient. Yes, I can ping that one. Let me see if I can ping the public side of my NAT server, which has the IP address of 209.209.209.30. So I can ping that. Let me see if I can ping the web server on the public. The IP address of it is 19.19.19.253, and then I access it through the web browser. Ping 19.19.19.253. I can ping it. Let me go ahead and use the web browser on PC1. Momentarily it's going to open up. Then I put the IP address of that web server, which is 19.19.19.253. Hit go. I access that website. Let me see if this PC can access the can access the web server that I have in my local area network, because we've already configured a static NAT for that one also. Go to the web browser of PC3, supposing that or pretending that I'm a user in internet, and I type the registered IP address of that one, IPv4 address of that one, which is 1. See if I can access. Yes, I can access it. Now let me check my NAT server show IPNAT translation. See if any translation has occurred. Yes, translation. Accessing the web server that we have through port 80, destination port 80. That address is public translation of this private IP address that this server has. The source device that accessed the web server that we have using the static NAT that we have configured on the NAT server is this device, random source port address. This is also related to the same connection, because we did that one more time when we created a static NAT. Now, this registered IPv4 address in the pool that we created was used with this random source address by this local device with that actual local IP address using this random port address to access the web server in the public with the destination destination port address of AD using HTTP, and the actual IP address of that web server is the same. It's a registered IPv4 address, and port AD was used. So both static NAT and dynamic NAT with a pool working in here. Now that we have created the static NAT for computers from internet access this server in our local area network, and we have configured the dynamic NAT with pool to be used by these local PCs to access internet. Notice that we put only 5 registered IPv4 addresses in the pool. So the 6th device should wait for the connection to be released by the local PCs that we have in order for that 6th device to go to internet. So you'll notice that creating a NAT with a pool is not very efficient. The more efficient way is to create a PAT, to create an overload. With one registered IPv4 address, you can have 4,000 simultaneous connection to internet. So we are going to configure PAT. Remember, also with PAT, you can add a pool, but we are not going to do that. It's the same as NAT with pool. We just create a PAT. In order to create PAT, the command is IP NAT inside source list 1. The same access list that we created would work in here. Then we don't put the keyword pool. If we have a pool, we can create a pool. And if you have a pool, we can use it. But since we don't want to use any pool with the PAT, we just use the keyword interface. Which interface? Serial 000, the actual registered IP address that we assign to that serial interface, and the keyword overload. That's it. PAT is created. Now let me go for this one. Also, I need to have the access list that I created for the dynamic NAT, which was this one. Access dash list 1 permit 192.168.1.0.0.0.255. Why 1? Because in here I said use access list 1. I can press enter and create and execute this command one more time. I've already done it. It wouldn't make any difference. I do it anyways. I have to indicate which interface is inside interface, which interface is outside interface. Since we've already done that for the previous 2 types of NAT, we don't have to do it again. But in order for you as a watcher of this video, do not assume that it is not needed. We are doing it one more time. Interface G00, IP NAT inside, exit. Interface serial 000, IP NAT outside, IP NAT outside. That's it. PAT is created. We could have created a pool with NAT also. Then over here, instead of interface, we would have put pool, the pool name, the keyword overload. We didn't create a pool for PAT. This is port address translation, meaning one registered IP address with a combination of uh, a number of the port addresses can be used for translating public addresses in the local area network to for the private IP addresses in the local area network to a public network address. 4,000 simultaneous connection can be done with one registered IP when we are creating PAT. So it is much more efficient than NAT. The static NAT is something unique. We need it if we have a device in our local area network in the private network that must be accessed by internet. So I would consider both static NAT and PAT as the ones that are going to be used more often than not. It is possible to use a pool with PAT also. So PAT and static NAT and possibly PAT with a pool are the most useful one for connecting to internet if you have devices in a private network. Let's see if this device is going to be able to go to that web server. 19.19.19.253. Yes, it can. Let's see which uh, NAT or PAT was used for this particular one, and show IP NAT translation. It is using overload because the IP address of the serial interface that we have on our NAT server has this IP address. It's using PAT instead of the NAT. Okay, let me try one more time from this PC. Let's go to the web browser. 191.1.253. We are accessing it. Let's perform the show command one more time. See, it's using overload. Both last two connections that we had to internet, overload was used. The same IP address that we assigned to our serial interface, serial 000 of NAT server, is being used with combination of random port addresses to use PAT, port address translation. The first one was used by this private device, which is PC2. The second one was used with this private device, which is PC1. Both of them accessed this HTTP server on the internet. So that's how you configure PAT. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.